Hello, welcome back. The title of this lesson is called Solving One-Step Equations with Addition and Subtraction, Part 1. I can promise you that the title sounds difficult, but it's actually quite simple to do this kind of thing. We're going to learn how to solve equations in this lesson. And actually, the last couple of lessons that we've done in simplifying expressions are actually much more involved than what we learn here. But the idea of solving an equation is going to stay with us throughout the rest of your math education on into advanced physics and calculus. I mean, you just never get away from solving equations. We want to figure out a systematic way to figure out what the value of the variable is that makes the equation true. And that's what we're going to learn here. So let's just start with an example. It's going to be much easier to explain. Let's say I give you the equation c plus 3, and it's equal to 5. Now, c is some unknown number. I don't know what it is, but it's something. Now, in real life, the equations are much more complex than this, okay? We have to start somewhere, but I'm just going to give you a flavor. We have equations to predict the motion of a ball when you throw it through the air. We have equations that predict the strength of gravity between the planets. We have equations that predict the orbits and how the orbits of the planets go around the sun and the moons go around the planets. We have equations for the temperature in the center of a hurricane. We have lots of equations for lots of different things. There are equations that talk about how time flows around a black hole. So these are really simple equations, but you're starting a journey on beyond which, as you continue, you'll get to learn some of the most fascinating things that humanity has ever figured out. But we're starting with these simple ones, and everything beyond this will build on what you learn now. So even though they look really simple, and they are simpler, they are going to build the skills for you in the future. Now, this equation you can solve without actually doing anything because you're asking yourself what value of c is such that when I add it to 3, I get an answer of 5. Whatever c is, it has to be a number. So when I add 3 to it, it's going to be 5. What number should c be? C has to be 2. Because if I take and I put 2 into here, if c has a value of 2, then if I add it to 3, I get 5. So you see, a lot of students say, oh, I can do this in my head, no problem. But the problem is when I get into more complex equations, you will not be able to do them in your head. So I'm going to teach you how to solve these things. Even though you might see the answer, that's cool, that's great. But you have to learn how to do it without guessing because the equations get more complex very soon, all right? Now here is the number one thing I want you to remember about equations. An equation is like a balance. It's like a balance, and the left side of the equal sign and the right side of the equal sign are in balance. And if I put a bag of sand on one side of the balance, it's going to go down. So in order to make it equivalent, I have to put another bag of sand on the other side. So what I'm trying to say is if you consider going to a playground, right, you may have a balance. You may have one person over here and one person over here, right? So let me put like one person right here. And these people have exactly the same weight, exactly the same mass. And of course, I'm not a good artist. But this equation, this equal sign is right here at the balance point. That's equals. And the left-hand side here is equivalent to the right-hand side. That means they're in balance. Now, if I go and I put a bag of sand on this side, if I just like drop a bag of sand right there, of course it's going to tilt this way. It'll be out of balance. So the only way for me to maintain balance is for me to drop another bag of sand of exactly the same mass or weight on the other side, and also the same distance away from the center. I mean, my drawing's not perfect. In order to keep an equation balanced, you can do whatever you want to one side of the equation as long as you do it to the other side of the equation also, because then you keep the thing equivalent or balanced. In other words, if I choose to add 5 on this side, it's going to be completely unbalanced because, of course, it was equal before, and I just add 5 over here, then it's unbalanced. That would be like adding the sand. But if I add 5 to this side and I add 5 to this side, then the equation might look a little different, but it's still in balance because I did the same thing to both sides, just like this. So with equations, you can add numbers to both sides. You can subtract numbers from both sides. And later on, we can also multiply numbers to both sides. And we can divide both sides by the same number. Later on, we'll do other things like raise both sides to the same exponent or other things that we'll talk about later as well. It never really ends, but the bottom line is you have to do the same thing to the left that you do to the right. So in this case, we have a situation where we have a number c and we've added 3 to it. So what we want to do to figure out what c is, of course we know what c is here, but to solve it in the proper way, we want to get c by itself on one side of the equal sign. We want to basically get rid of the plus 3 that's here, and that will put c by itself, and then we will have solved the equation. So if we have a plus 3, how do we get rid of the 3? Remember, we can do whatever we want to both sides. Let me show you what we do. Let's rewrite the equation. C plus 3. I'm going to give myself some room, and I'm going to put the 5 here. I've just rewritten what we have here. I can do whatever I want to both sides as long as I do it to both sides. So I'm going to, instead of adding here, I'm going to do the opposite operation. I'm going to subtract 3 from the left. And because I'm doing it to the left, to keep it balanced, I have to do it also to the right. If I subtract 3 from the left, I have to also subtract 3 from the right. If I subtract 19 from the left, I must also subtract 19 from the right. You see the idea? If I add 25 to the left, I must also add 25 to the right. If you don't do it to both sides, what you've done is not legal, and it doesn't work. So here, we've done a subtraction of 3. It's the opposite of the adding of 3 that we have done here. Why do we do that? Because 3 minus 3 is 0. Right? So what you have is when you have 3 minus 3 is 0, poof, it disappears from the equation, and all that we have left on the left-hand side of this equal sign is c. On the right-hand side, 5 minus 3 is 2. And now we have the letter, the variable, on one side of the equal sign by itself, and on the right-hand side, we just have a number, and we figured out that the variable that makes this thing true is c has to be equal to 2. And that's what we already knew by just looking at it and guessing, right? You can always check your work by taking the value of 2 that we got for the answer and sticking it back in here. 2 plus 3 does indeed equal 5, so it is the correct solution. The nice thing about equations is you can always check your answer. Always, literally. Just take your answer, stick it back in, and see if it works. Because the value of c is a placeholder. But now I'm telling you that c must be 2. So if we check it, we put 2 in, yes, it does equal 5. So that's going to be the pattern to every equation you ever solve. We have to identify the opposite operation, and we're going to do that operation to both sides. And then the goal will always be to put the variable on one side of the equal sign by itself, and then the other side is just whatever number falls out, and then you know what the variable is equal to. Here, we were adding 3, so we did the opposite. Subtract 3, that's because we're trying to get rid of the number over here. We're trying to get rid of the 3. Okay, now let's go through more examples, and you will see how easy it is to do this. X minus 4 equals 1. Now I know that you can look at this, and I know that you can guess what x is equal to. That's not the point. The point is these equations will get much harder very soon, so we have to do it the right way. So let's write down our equation. Let's give ourselves some room, and let's think about what we have to do. We have subtracted 4 from the left. So the opposite of addition is subtraction, and the opposite of subtraction is what we call addition. You always do the opposite thing to get rid of the number on the left-hand side. So since we have subtracted 4 here, we want to do the opposite, which is just adding 4. But if we do it to the left-hand side, we have to do it also to the right side to keep it balanced. Now on the left-hand side, we have minus 4 plus 4, and yes, I haven't totally taught you that negative 4 plus 4 is 0, but I think you can see that that is true, because we've been rearranging things when we need to, so you could easily say this is 4 minus 4. You could take it and put it on the other side. The bottom line is minus 4 plus 4 is 0. You could also think of it as if I owe you $4, this is what negative 4 means, owing $4, but then I get $4 given to me, then what do I have? If I owed you $4 and then someone gives me $4, then I have nothing because immediately I had to pay you. So this becomes 0. The only thing left is x, and then 1 plus 4 is 5. So we know that 5 is the answer. We check it by putting 5 in here. 5 minus 4 is 1. So we know the answer is correct, just like we could check the previous one. That is literally how we're going to do all of these problems. Let's take a look at the next one. K minus 3 equals 6. We're going to rewrite it. K minus 3 equals 6. Give ourselves a little bit of room. Here we have subtracted 3. So what are we going to do to get rid of it? We'll do the opposite. We'll add 3. And if we do it to the left, we must also do it to the right to keep it balanced. So on the left, we have minus 3 plus 3. Or if you want to think about rearranging it, 3 minus 3 is 0. Either way, this is going to become 0. All you will have left is k. And then 6 plus 3 is 9. And the answer is k is 9. Let's check it. Let's put a value of 9 into here. 9 minus 3 is 6. So we just checked it and made sure that it is exactly correct. There is only one value of k that will work. If you put other values of k in here and subtract 3, you're not going to get 6. There's only one solution to this equation. When you figure out what the variable must be equal to, we call that solving the equation, or you have found the solution of the equation. All right. Next problem. We have a few more, and they're not going to be any harder. We're just getting more practice. What about w plus 6 is equal to 13? So we need to give ourselves some room. We have a plus 6, and we have a 13 on the right. Now, we have been adding 6 on the left, so in order to get rid of it, we do the opposite. Subtract 6 from the left, subtract 6 from the right. 6 minus 6 is 0, so that all that is left on the left is just w. And the right, 13 minus 6, is just 7. So we get an answer of 7. You see how easy that was? We just do the opposite. Subtract 6, subtract 6. This goes to 0. W is left. 13 minus 6 is 7. Let's check. 7 plus 6 does indeed equal 13, so we know we have found the correct and the only answer to this equation. Now, all of these equations are simpler, and they're only going to have one answer. But as you get higher up in math, there are different kinds of equations, not these kinds, but there are other kinds of equations that have more than one answer. Actually, some equations have infinite number of answers, and that's just way down the road. I just want to let you know, equations don't always have one answer. They can sometimes have more than one answer, but all of these that we're doing here will only have one answer. All right, let's take a look at the following. 8 is equal to y plus 1. Now, in all of the previous problems, the variable was on the left. The variable was on the left, all the other problems. Here, the variable, the unknown, is on the right. It doesn't matter if the variable is on the left or on the right. It doesn't matter. All you're trying to do is put the variable somewhere on one side of the equal sign. Doesn't matter if it's on the right or on the left. Just get it by itself on one side of the equal sign. So let's rewrite what we have. We have 8 equals y plus 1. Now, we want to get y by itself, but we've added 1 on this side. How do we get rid of that? We do the opposite. So we subtract 1 from that side, and we subtract 1 from the other side. We keep it in balance because we have subtracted 1 from both sides. On the left, 8 minus 1 is 7. And on the right, 1 minus 1, this term right here, it goes to 0. So all we have left is 7 equals y. Now, if 7 equals y, then we can flip it around and just simply say that y is equal to 7. When you have something equals something, you can just flip the thing around, and so y is equal to 7. This is the answer. Let's check. If y is 7, stick it in there. 7 plus 1 does indeed equal 8, and so we know we have found the correct and the only solution to this problem. All right. We are over halfway done with this lesson. Let's take a look at g minus 8 is equal to 2. All right, so we rewrite the problem, give ourselves a little more space. G minus 8 is equal to 2. Now on the left-hand side, we are subtracting 8. We want to get g by itself, so we're going to do the opposite. We're going to add 8. And so to keep it balanced, we'll have to add 8 to both sides. All right, now on the right-hand side, 2 plus 8 is just 10. On the left-hand side, what happens here? Negative 8 plus 8 is 0. It's like if I've borrowed $8, that's what negative 8 means, but then someone gives me $8, then I really have nothing, because as soon as I get the $8, I have to give it back because I had borrowed it to begin with. So, or if you want to think of it as flipping it around, 8, move this over here, minus 8 is 0. And so either way, this goes away, and so you just have g is equal to 10. And let's check. Put 10 in here. 10 minus 8 is 2, so we know that we have found the correct and the only answer. All right, only 2 more problems. Let's take a look at 9 is equal to f minus 5. Variable is on the right. That's okay. Let's rewrite everything. F minus 5 here, and I wanted to give myself a little more space, so let me put that right here, like this. All right. Now, on the right-hand side, I want to get f by itself, but I've subtracted f, so in order to do the opposite, I have to add 5. I may have misspoken. What I meant to say was I'm subtracting 5 here, so I'll do the opposite of adding 5. And so I'm going to have to do the same thing to the right, or to the left. 9 plus 5 is 14. And on the right, all we have left is f, because negative 5 plus 5 is 0. When you add the opposite or subtract, negative 5 plus 5 just cancel each other out completely. Or if you want to think of moving this to the other side, 5 minus 5 is 0. Either way, you just have f. Now we can flip the order of this. F is equal to 14, and 14 is the final answer. Let's check. Stick 14 in for here. 14 minus 5 is actually equal to 9, so we know that it's the correct answer. And here is our last problem for this lesson. it is p plus 11 is equal to 20. Let's rewrite the problem. P plus 11 equals 20, just to give ourselves a little room to work. All right, so we've added 11. We want to get rid of this, so let's just subtract 11. We'll do the opposite operation. And so what do we have? 11 minus 11 is 0. P is the only thing left on the left-hand side. 20 minus 11 is 9, and so P is equal to 9. Let's check. Put a 9 in here. 9 plus 11 is 20. That is the correct answer. I want to share with you a story. Once upon a time, I knew a really bright young person. And he was so good that he could look at equations like this and just know the answer. Just like you could probably look at this and probably figure out that 9 goes in there. And because he could do everything in his head, he never really wanted to write anything down. And it really worked well for a while, but pretty soon the equations got a little more complicated. Then he continued trying to do things in his head. And eventually it gets to the point where you can't do it in your head anymore because none of us are human calculators. I am not a human calculator, and I make tons of mistakes all the time. But eventually, those skills, like I'm showing you here of writing everything down, they were not built properly. So when he got to the more complicated equations, he started doing really poorly in math and just lost interest in math. I want to encourage you to do the opposite path. Please, just believe me, trust me. I know what I'm talking about. I know that you can look at these and I know that you can guess the answer to these equations. That is not the point. I'm choosing easy problems for you so that you can guess the answer because I want you to see the answer is correct very easily. That's why I'm making these so easy to check, I should say, right? But what I want you to do is really focus on the process. If you've added 6, then the very next step to get W by itself, you have to subtract 6 from both sides. Here, we have subtracted 3. To get K by itself, we have to add 3 to both sides. And I can go through the other examples and do the same thing. You're just doing the opposite operation. Then, in the next step, you convince yourself this goes to 0, the variable's by itself. This calculates to the answer. Because very, very soon, I will give you equations that you cannot do in your head. And you have to get good at writing it the way I've done it here. Subtract 11, show your work all the way. And that way, if you make a mistake, which you will, then you can look back and see where was my mistake. And if you don't write anything down, then no one can fix their own errors. And everyone makes errors. Please just trust me on this. So I will tell you one last thing, and that is that the most famous mathematicians, the most famous scientists, the most famous engineers in all of history, and I'm talking the big ones, Isaac Newton, Albert Einstein, there's tons of others, Richard Feynman, I could go on, they always wrote their work down. None of these people, the brilliant people that we think have contributed so much, none of them just did it in their head and just said, oh yeah, that's it. None of them, 0 of them. And that's in chemistry, biology, any branch of science or math or engineering. They write their things down. So please get your pencil, write it down so you get good skills. So in a few lessons, when we get to harder things, you will know how to write down things and you will then show your work and you will do well. Instead of getting discouraged, trying to do it all in your head. Please follow me on that piece of advice. Now, solve these yourself. Follow me on to part 2. We will continue solving one-step equations with addition and subtraction.